Hello students, welcome to my channel Explore Physics, Let's Explore. In the previous class, I have explained you about the electric charges, conductors and insulators, electric current and the symbol for the electric components. Today I am going to explain you about the electric potential, resistance, resistivity and Ohm's law. So what is the factor responsible for the smooth flow of electric current in a circuit or through a conductor? The main factor responsible is called electric potential. So you have seen the cells, dry cells or the battery cells which you use in the torches or in remotes and all. After some times, when the chemical inside it is completely used up or consumed, it ceases to give the current or the charge. Why? Because the electric potential, the potential difference between its two terminals is zero or it's no more there. The electric potential or the potential difference we are going to discuss today. Say, let's assume we have one test charge, small q, one positive test charge q, and it is somewhere closer in the electric field of another charge that is plus q. So this is the source charge plus q and this is the test charge. This is also plus q, small q. This plus q will experience an electric force or force of repulsion because of the electric field produced by this charge. This source charge plus q will have the electric field around it because it has the electric charge, and this another test charge that is plus q, again small q plus q, this will experience an electric force because it is placed within the electric field of this source charge. If I am going to take this charge from this place, I have to move this charge, this test charge. What will happen? I have to apply the force which overcomes this force of repulsion. For this, I have to do some work. Let's assume that work done is W. Are you getting it? What did I tell you? We have a source charge plus Q. Because of its electric charge, it has the electric field around it. And within that electric field, we have placed one more unit positive charge. These both are unit positive charges. So we have one test charge placed here. So this test charge is experiencing a force of repulsion because it is within the field of this plus Q. So if I have to take it away, I have to move this test charge to some other place. I have to put in the effort, or I have to do some work to overcome this force. Let's assume this work is W. So what will happen? I have to do this work to take this plus Q to some other place. That is the electric potential, which is denoted by V. So V is equal to W by Q, where W is the work done, Q is the charge. So what is V is equal to W by Q? How can I define it? The work done to bring one positive, unit positive charge from infinity to any point is called the electric potential. So you have to put it in the definition V, W and Q. So I'm repeating it again. Electric potential is the work done to bring unit positive charge from infinity to any point. That is electric potential, denoted by V, measured by voltmeter. Like we have a meter to measure the electric current, we have voltmeter to measure the electric potential or the potential difference, and this is always connected in parallel, denoted by this symbol in a circuit. What is electric potential difference then? You know that the water flows from higher to lower level, heat energy flows from hot to the cold object. Same things is there. The electric current will flow only when the potential difference is maintained between the two terminals of a conductor or of any object for that matter. Potential difference is actually the difference between electric pressure. So like for the cells and all, for all the things we have plus and minus two terminals. So let's assume the dry cell or any cell, if the difference in potentials or difference in electric pressure is there between these two terminals, till then only the electric current will flow. If like in the cell, when the chemicals are consumed or are used up, there is no potential difference, both have the same electric pressure, both the terminal, then it will stop giving you the electric current. So the potential difference is the main factor which is responsible for the smooth flow of electric current. It is also called the voltage. And what exactly is that? This is again the same thing, work done to bring 1 coulomb of charge from one to another point, or work done to move one unit positive charge from one point to another. Electric potential difference, because the term difference is there, so we are talking about the two terminals, because the difference has to be there. So for the difference we need two quantities, two physical parameters. So that's what the potential difference is. The unit is volt with small v. So what is the potential unit of potential difference or potential? Volt or v. So I can also say that if I am giving you the unit definition, 1 v is equal to 1 joules per 1 coulombs. So what is 1 v? What is the unit definition of electric potential or 1 volt? That when 1 joule of work is done to bring 1 coulomb of charge from one to other point, the potential difference is said to be 1 volt. Or when 1 joule of work is done to bring 1 coulomb of charge from one to the other point, then the work done is called electric potential. Only thing you have to include in your definition all the three physical quantities. Voltage should be there, or electric potential or electric potential difference should be there. The work done should be there, and the charge should be there. So I am once again repeating it. When 1 joule of work is done to bring a unit positive charge from one to the other point, the electric potential is said to be 1 volt, measured by voltmeter. Voltmeter is always connected in parallel. So this is all about the electric potential or electric potential difference, the main factor responsible for the smooth flow of electric current. Now we'll talk about Ohm's law, and from there, what is a resistance? Ohm was the physicist who said that the electric current flowing in a circuit is always proportional to the potential difference across its ends until the temperature remains the same, or provided the physical conditions remain the same. Or again I am telling you that the Ohm's law states that the electric current flowing in a conductor is always proportional to the potential difference across its ends, provided the temperature remains the same, or provided the physical conditions remain the same. Any one of thing you can take, either temperature remains the same or physical condition remains the same. I can also write this: I is directly proportional to V, or V is directly proportional to I, or V is equal to IR. To remove the proportionality sign, we always have to introduce one constant. So this constant of proportionality is referred or is called resistance. Resistance of the conductor, denoted by capital R. So V is equal to IR, where IV is the electric potential or potential difference, I is the electric current flowing through it, R is the constant which depends on the temperature, the length, area, electric current and electric potential flowing in the circuit. So we'll talk about resistance now. So because from this Ohm's law only we derived or deduced that resistance R is actually the obstruction in the flow of electric current. Assume that we have one river flowing. If there is a stone in it, so this obstruction, just assume this obstruction is what? Is the R. If the obstruction is big, to the other side we will not be getting the enough flow, proper flow. So this flow you assume that I. If the obstruction is big, to the other side we are going to get less I. If the obstruction is small, we are going to get enough I to the other side. So just what is resistance? Is the obstruction or obstacle in the flow of or in the path of electric current, denoted by R. SI unit is ohm or omega. We can also show it like a Greek letter omega, and is equal to, from V is equal to IR, Ohm's law. R is equal to V by I. So it depends on the electric potential and the electric current, inversely proportional to electric current. If the electric potential is double for any conductor or a circuit, resistance also will be double. If the current flowing through it is double 2I, then R will become 1 by 2, half of the original resistance. SI unit is ohm. Formula I have given you. Again we can find the unit definition for resistance, 1V by 1 ampere. So what is 1 ohm? If the potential difference between two terminals of a conductor is 1 volt and the electric current flowing through the circuit is 1 ampere, then the resistance of that conductor is said to be 1 ohm. Again, all the three things you have to include in your definition. I'm repeating it again. When 1 volt of electric potential difference is maintained through the terminals of a conductor and 1 ampere current is flowing in the circuit, then the resistance is said to be 1 ohm. So this is the definition of 1 ohm, unit definition of 1 ohm. The alternate unit of resistance is volt by ampere. Right? This Ohm's law can be verified in the lab. You have an experiment based on Ohm's law where you have to verify that electric current is directly proportional to the potential difference. And what do we do for verification? How do we verify Ohm's law? Again we are going to take the simple circuit and we will see that the law says that I is directly proportional to V. So here we will be taking along x-axis we can take I, along y-axis we will take V. So when these two are directly proportional to each other, so we will get a straight line. This verifies that the Ohm's law for the ohmic substance, it is true. The slope of the graph is a straight line. So slope of the graph gives you the resistance. So slope means, say this is, I have taken 2 points here. Say this is A, this is B. I am going to drop one perpendicular here on x-axis, 2 perpendicular, one from A and one from B, and I am going to put this here, one perpendicular to this side. So this AB. Slope of the graph is AB, which is equal to tan theta. Again it is B if it's C. So this is BC upon AC, that is tan theta. So BC by AC, this is the slope of the graph. So slope of the graph is what? AB, which is equal to BC by AC. What is BC here? V. What is AC here? I or delta I. I can say delta V by delta I. So this is delta R. So slope of the graph will give you the resistance of the conductor. It's a straight line because V is directly proportional to I or I is directly proportional to V. This is what you have to verify in the lab. You can, refer the site O Labs, children. This is, if you just Google O Labs, you'll get all the, for 9, 10, 11, 12, all standards, the practicals there. You can even do it. There is a video also, stimuli also, where you can do it on your own. So it's very useful site. Amrita Engineering College, they had through CB with the collaboration with CBSE, they have set up the lab there. So this is verification of Ohm's law. This resistance, I hope it's clear to you. This resistance is also directly proportional to one length of the conductor, two inversely proportional to 2A, that is area of the conductor. So here I'll write directly proportional to. To L. So if you combine it, R is directly proportional to L. I'll write it here. That implies R is directly proportional to L, and here that implies R is inversely proportional to area of cross section, that is 1 by A. If you combine it together, R is directly proportional to L by A. If I am going to remove this proportionality sign, I have to introduce one constant. So R is equal to rho L by A, where this rho is called the resistivity of the conductor. So this rho is the resistivity of the conductor. It does not depend, although if you just do it, you can just say that rho is equal to, it's a Greek letter again, rho, R-H-O. But if you see it, rho is equal to R-A by L. But it does not depend on the dimension of the conductor. Always remember, very important question for your Viva and for theory also. R is equal to rho L by A. So rho is equal to RA by L. But it does not depend, it's a constant of proportionality which differs from material to material, but it does not depend on the dimension like area and length of the wire. If I am going to take 1 meter wire of copper and 2 meter wire of copper, so it doesn't mean that it's going to change. It will be the same. It only changes from material to material, whereas R is directly proportional to L by A. So if you have 1 meter of wire, like I've told you, and now you have taken another wire which is of 2 meter, definitely, because it depends, it is directly proportional to L. So if I, instead of 1 meter, I'm going to take 2 meters, so resistance also will be double of that. If I'm going to half the area of cross section A by 2, so this R will become 2R. This resistance depends on the length, area of cross section and the temperature, but this depends on L, A and temperature, directly proportional to L, inversely proportional to area of cross section, directly proportional to temperature, but the resistivity will only differ from material to material. It does not depend on the physical dimensions of the conductor or of the wire. The range of resistivity, like conductors, if I am talking about the conductor which allow electricity to pass through them. So when the electricity is passing, the electric current is passing, it means they have less resistance. Okay, like for instance, if we have we have thick wire. So if the wire is thick, means A is more, R will be less. If area is less, thin wires, R will be more. R resistance will be more means less amount of electric current will flow through it. Area is more means resistance is less. So more resistance is the, just remember it is the obstruction or obstacle. So when A is more, R is less means the smooth flow of electric current is possible there. L is more, R will be more, L will be less, R will be less. But here because it is inversely proportional, A is more, R will be less. R will be less means related to electric current will flow easily. A is less, it is inversely proportional, R will be more. R will be more means is the more obstacle, so electric current will flow less. Related this way. What is the range of resistivity? So range of resistivity of range of rho, I am telling you, for conductors or for alloys, the range is from 10 to the power minus 6 to 10 to the power minus 8. Its unit is ohm meter. What is the unit of rho? This is, see, R ohm, A is meter square, or length is meter. So what is the unit? Ohm meter. So unit of resistivity is ohm meter. So conductors, the range of resistivity for conductor is for 10 to the power minus 6 to 10 to the power minus 8 ohm meter. For insulators, insulator means they do not allow the electric current to pass through them. The resistance should be very high. So it will be around 10 to the power 12 to 10 to the power 17 ohm meter. This is the range for resistivity for insulators. More value, more resistance, less flow of electric current. We discussed today the electric potential difference, Ohm's law, the verification of Ohm's law, resistivity, on which factor the R depend, on which factor the resistivity depends, and the ranges of resistivity for insulators as well as for conductors. That's all for the day. Stay safe, stay healthy, and a very big thank you to you all. Bye-bye.